Okay, so we're going to look at something called the surface area of 3D shapes. If the shape is just 2D, so if we just had a square, oops, better get a pen here. If we just have a square like this, then we're just finding area. Okay, that's because this is 2 dimensions, it's flat on the board, there's no depth to this. If we turn this into a 3-dimensional shape, some sort of box or a cube, then we're looking at surface area, because there are multiple sides and we have to add up all of those pieces to get the total area around all sides of the shape. So one is 3D, one is 2D. We're working with 3D today. Okay, so a rectangular prism. So the surface area is the area of all the sides. Please note in some problems that the top will be cut off, sides will be missing. We have to do some interpretation. So what we do work with is sometimes is a net. So if you imagine this as a box and you unfold it, this would be the bottom, these would be the side edges. So if you've ever taken a cardboard box apart before, it looks something like this. Okay, so and then we can match up the dimensions. This could be width times length. This side here could be length times height, which makes this is length times height. So that's this side right here is this guy. Okay, and then the front side, this one here, I've changed colors. This front side here would be W times L, so there would be another W times L here, and I have the one in the middle incorrect. No, sorry, W times H. This one should be H. The one in the middle is correct. Let's go back here and fit that in. This is W times H. W times H. Now that's 5 sides, so I'm still missing another piece here, and I'm going to just move this expression here over, and I'm going to add the top. So the top would have to go here, and it would be another W times L. Okay, so that's a quick version of a net. It's kind of messy, I understand. I'm just trying to do this relatively quickly for a rectangular prism. But what we should understand is there are 6 sides. So what you will notice, though, is that because there's repetition, the formula will sometimes be written like this. Because there is 2 of each one of these combinations. Okay, and that gives me the 6 sides. Now, if for some reason they did not include the top of the box, then you'd be down to 5 sides. If they just did all 4 sides, they cut the top and the bottom off, you'd have to make adjustment to the formula. So this formula right here is only if there are 6 sides. Okay, and being able to draw a net is a very handy skill. We'll do that a couple times today. So a triangular prism looks something like this. So again, it would have, let's move that word net out of the way. It would have a base that looks something like that, and the dimensions would be width times length. Then there'd be a couple sides that fall out. So on the side, there's another rectangle. That's this guy right here. That's the sides we're looking at. And then there would be these triangles on the end. Okay, so that's our rough net of what this looks like. It allows us to put some dimensions on things. So the area of these end pieces here, this would have an area of 1/2 times the width times the height. And now this one on the side here, this is the tricky one that gets most people. Okay, so this has an area. Okay, it's definitely L times something. Okay, and it's not an H, and this is where people get a little bit confused. This dimension right here is not the height. It's something we call the slant height, and we'll talk about that in 2 seconds, and I'll show you how to calculate it. So this would be the slant height, and it would be that dimension right there. Okay, so if we were setting up a formula for this, we would have one base of W times L, whatever those dimensions are. We would have 2 triangles of 1/2 W times H. And again, it doesn't matter what the letters are. Don't get tied up in the letters. Okay, and then we would have these two rectangular sides that go on here, and in this case they are L times S. Okay, so if you count them up, there's 1, 2, 3, 4, 5 sides on this triangular prism. And if you count these up here, I have one bottom, two sides, two triangles, and this is the same thing as 5. Okay, so let's just deal with this slant height. Height versus slant height. So stop and take a look at this. This is a really important piece because when I show you the formula sheet, they're going to have little S's on there and we need to know what that is. When we look at this triangle, slant height is the side that is that's measured on an angle. The height and the base always meet at 90 degrees. Okay, so the height is straight up, the slant height is on an angle. That's really, really important. It's leaning. It's not the same as the height. I can't emphasize that enough. But what we can see is, hey, if that meets at 90 degrees on the base, there's a right triangle involved here. So I can use my Pythagorean theorem to relate these pieces together. Okay, so if I call this slant height, this is the true height of the triangle, and then this bottom piece is half of whatever the base dimension is. Okay, and we can use Pythagorean theorem to be able to solve for those missing pieces. So let's try that. Square-based pyramid. So now surface area for this one. We'll do that. We'll do the calculation in a minute. Square-based pyramid would look something like this. There's the base. Now there are 4 triangles that come off of that base that all fold up. Okay, now the dimensions though, the bottom, we would have a W squared, that's the square, and then I'm going to change color here. This triangle right here, and there's going to be 4 of them, it has a base dimension of W, but this dimension right here, this is the height. Maybe I'll use this triangle, it might be easier to see it. The height is right here. Well, that height falls on the picture right there. It's a slant height. Okay, so this triangle would have 4 triangles. Sorry, this pyramid would have 4 triangles that are 1/2. In this case, W times the slant height, where this is S. Okay, and so we would have to use our height, our half of our width or base, okay, and I would use our Pythagorean theorem to solve for that slant height. Okay, last one, I think, second last one, circular prism. Okay, so if I want to find the area for this one, there are 2 small circles, which you can see here and here, and a rectangle. So if you've ever rolled up a piece of paper to make a tube, that's how we create a cylinder. Now, this dimension right here, if we were to look at this as a circle, that is the circumference, and it is 2 pi r. Maybe I'll write that in a different color. The circumference or the perimeter of that circle on the top is 2 pi r, but if you cut it and unfold it, that gives you this dimension of the rectangle. Okay, so when we go to set up our expression for a surface area of a circular prism or a cylinder, we would have 2 pi r squareds. Okay, and that's these 2 circles here and here. And then I want to also add to it 2 pi r times h, which is the area of this rectangle. Okay, and again, as I've noticed or said before, you are not responsible to memorize formulas. Everything we've looked at here is on this sheet. You will always have these formulas provided. So pause the video, download this off the website, go to EQAO if you need to and get it from there. All of these formulas, you should be able to read the picture, look at the formula and go, okay, I know where those pieces come from. Okay, but you will never be asked to memorize and work with them that way. Okay, so let's actually do a question. Determine the surface area and volume of the following. So I have a square-based pyramid, not a prism, a pyramid. Okay, and I want to find both surface area and volume. So let's do volume first because that's going to be the quicker of the two. So this is 1/3 the base area times the height. Okay, and so what I'm doing is I'm going back to that idea that if I turn this into a prism, okay, the pyramid is just going to be 1/3 of it. Okay, that's the whole idea. So I have that formula or that understanding of what the shape is. You can always look the formula up and get it from there. Except the h here we actually know. We know the h is 10. So this becomes even quicker. So we have 1/3 144 times 10. So 144 divided by 3 times 10, 480. And the units on that would be meters cubed. Okay. Now surface area is the one that's a little trickier. So if we look here, we have surface area, we have the square on the bottom, plus 4 triangles that I have to add up on the side. I don't know the slant height, so I'm just going to draw my right triangle in here that I'm going to have to work with. Let's pop over to the side to actually work on that. So I have a triangle here that has a height of 10. It meets the base at 90 degrees. This bottom dimension would be 6 because it's half of the base, and I'm trying to find this s value. Okay, so let's set up our quick Pythagorean theorem. S squared, or hypotenuse squared, equals leg squared plus leg squared. So s squared equals 136. So 10 squared is 100, 6 squared is 36. So now we take the square root of that, 136, and we get 11.7 is this dimension right here. Okay, so now let's go back to our actual surface area calculation. We have 12 squared, there's the base. We have 4 triangles, which are 1/2 base times slant height. Okay, and then if I let my calculator do all of the heavy lifting, I can get the surface area. So there's 12 squared plus 4 times 0.5 times 12 times 11.7, and it looks like it's 424. Can't see my calculator in here, and the units on this would be meters squared. So just a reminder, area is measured in squared, volume is measured in cubes. Okay, so there's a couple questions to try. Thanks for tuning in.